Velocity is the pendulum's change in position over time, while acceleration is the change in velocity over time. Finding velocity can be done by finding kinetic energy. At the maximum height of the system, the pendulum has zero kinetic energy and therefore the velocity is zero. The centripetal acceleration was also zero because the velocity was zero. At the bottom of the pendulum system, the kinetic energy was equal to the potential energy. Say the mass of our pendulum was 16.1 grams and we caused a displacement of 0.5 meters. The maximum potential energy would be 0.07889 joules. This can be set equal to the kinetic energy at the bottom of the system, giving a velocity of 3.13 meters per second. The centripetal acceleration is equal to the velocity squared, divided by the radius. If the pendulum has a radius of 35.7 centimeters, the centripetal acceleration would be 27.44 meters per second squared. At the opposite side of the pendulum, the system once again has no velocity and therefore no centripetal acceleration. Period is the length of time for a pendulum to complete one cycle. Frequency is the amount of cycles in a second. The equation for period length is period length equals 2 pi times the square root of length over gravity. 2 pi and gravity are the constants, so the only factor that change period length is the length of the pendulum. Our three longest string lengths were 35.7, 33, and 30.6 centimeters. The period length for each respectively were 1.25, 1.15, and 1.11 seconds. There were two forces that acted on our system, gravity and the centripetal force. Gravity is the force of acceleration on a mass, while centripetal force is a force that makes a body follow a curved path. The force of gravity never changes in a pendulum system because the acceleration due to gravity and mass of the pendulum never change. The centripetal force changes as velocity changes. Centripetal force equals mass times centripetal acceleration. Since the velocity was zero at the first point, the centripetal force was zero because there was no centripetal acceleration. At the second position, there was a velocity of 5.42 meters per second, resulting in a centripetal force of 5.88 newtons. When the length of the pendulum is 5 meters, the third position at the bottom has a velocity of 7.67 meters per second, resulting in a centripetal force of 11.76 newtons.